In this video, I want us to talk about lattice energy. Now, in your A-level exam, you are going to be asked to define what lattice energy is. It is also known as lattice enthalpy. Now, to define this, you state that lattice energy is an enthalpy change when 1 mole of an ionic compound is formed from its ions under standard conditions. So, the terms I've underlined are very important. You have to state that you are dealing with 1 mole, you are forming 1 mole of ionic compound, and it has to be under standard conditions. Now, standard conditions here has to be a temperature of 298 Kelvin and a pressure of 1 atm or 101 kilopascal. Now, these are the conditions for you to define lattice energy. All right, so we are dealing with ionic compounds, and so we need ions, but then these ions has to be in the gaseous state. So for example, if you take an ionic compound such as sodium chloride, for sodium chloride is NaCl. Now, to form this ionic compound, we need sodium to be gaseous, sodium plus to be in the gaseous state. Okay, and we're also going to need a chloride, Cl minus, in a gaseous state. Now, the energy that is required for this to combine to give us sodium chloride in a solid state is what is referred to as the lattice energy. So what we have here is the lattice energy. All right. Now, the energy involved specifically in forming sodium chloride, the lattice energy involved is equal to minus 787 kilojoules per mole. So this is the energy involved in forming sodium chloride. What about magnesium chloride? For magnesium chloride, we also need magnesium 2 plus in a gaseous state, and this is going to be combining with 2 moles of chloride in a gaseous state as well to give us magnesium chloride. And the lattice energy involved here, standard, is equal to minus 2526 kilojoules per mole. So that is what lattice energy is. Now, we cannot just determine what lattice energy is through just a single experiment. Okay, so we'll have to look at other terms, other experimental data to be able to work out the lattice energy involved in a particular reaction. Now, before we go on, always remember that the state of the atoms you are dealing with has to be gaseous. Okay, and so take note that we need the atoms to be in the gaseous state. And also take note that the enthalpy change here is what is negative. It's negative. So that should tell you that it is an exothermic process. It is an exothermic process. Now, it is an exothermic process because we are combining this. They are in the gaseous states, and we are combining them to form the ionic compound. So the energy that is keeping them in the gaseous state is being given off. So that is why it is an exothermic process. Now, should we define this as the energy required to break the ionic bond, then it is going to be an endothermic process because you will need energy to break the ionic bond. All right, so 2 terms to look at. The first one is enthalpy of atomization. And the second one we are going to talk about is electron affinity. Electron affinity. So what is enthalpy of atomization? Now, enthalpy of atomization is the energy required to break all the bonds in 1 mole of a substance to convert it to individual atoms in the gaseous state under standard conditions. Now, once again, remember the standard conditions, we are talking of a temperature of 298 Kelvin and a pressure of 1 atm, okay, and a pressure of 1 atm. That is enthalpy of atomization. So what exactly does that mean? Now, if you take a metal like lithium, lithium would exist as lithium in a solid state. So if we have lithium in a solid state, we cannot just go ahead and add electrons to it. So what we need to do first is to break that metallic bond and have the atom free as a gas, okay? And we need energy to do that, and that energy is what is referred to as enthalpy of atomization. Now, this also is sometimes referred to as enthalpy of dissociation. So we need to convert solid lithium to gaseous lithium, and if we do that, the enthalpy there would be enthalpy of atomization, okay? Now the energy involved in this is 161 plus 161 kilojoules per mole. 161 kilojoules per mole. Now this means that it is an endothermic process, okay? So you need to take in heat to break those metallic bonds to get sodium to exist in the gaseous state, okay? So we are vaporizing it in that sense. All right, now what if it is not a metal, maybe a gas? So if you take something like chlorine exists as Cl2 in a gaseous state. Again, to get it to a single atom, we need to break that covalent bond between the two chlorine atoms. In order to balance this equation, I'm going to put half here so that I can have an atom of chlorine at the other side. So this is going to be gaseous, okay? So now the energy that is involved here again is enthalpy of atomization, delta H AT for atomization, and then the energy, specific energy involved in this is plus 122 kilojoules per mole, plus 122 kilojoules per mole. That is the energy involved in atomizing chlorine. All right, so you notice that the values here are positive, which means it is an endothermic process, okay? Now the last value we want to, the last experimental data we also need to be able to work out the lattice energy is the electron affinity. Now electron affinity, which is simply represented as EA. Now this one is the enthalpy change when 1 mole of electrons is added to 1 mole of a gaseous ion with a single negative charge under standard conditions. Now this is specifically known as first electron affinity. Now because we are adding only 1 mole of electron, we know that there are other atoms that can take more than 1 mole of electron. In adding the first one, we'll call it first electron affinity. If we need to add a second one, then it's going to be the second electron affinity, okay? Now, so again, your standard conditions, you should always remember them. That temperature is 298 Kelvin and pressure is 1 atm, okay? Pressure is 1 atm. All right. Now, chlorine is one of such atoms that would love to accept electron to form chloride in order to have a noble gas configuration. So if you take chlorine in a gaseous state, we need to add 1 electron to it. You need some amount of energy to be able to do that, because you know that in adding electron, you're definitely going to experience some repulsion from the inner electron, which is known as shielding effect. Okay, so the energy you need to overcome this to be able to form a chloride is what is the electron affinity. Now, in this case, we are adding the first electron. There's only 1 electron, so we'll call it the first electron affinity. And the specific energy involved in this is minus 348 kilojoules per mole. Minus 348 kilojoules per mole. All right. Now, you can have a similar thing for any other element that would accept electron, like sulfur. We take sulfur in a gaseous state and you add 1 mole of electron. We are looking at the first electron affinity of sulfur because we are adding the first electron. So EA1 for sulfur is minus 200 kilojoules per mole. Okay, now always take note that it is what a gaseous atom, and then we are having what a gaseous anion. So the state is what gaseous, and then the energy change involved in this first ionization, electron affinity, is exothermic. Okay, it's exothermic. All right. Now, like I mentioned earlier, in adding subsequent electrons, you have to take note that you would have to be dealing with the second. So the first electron that is being added is, you need what? First electron affinity. For the second one, you need the second electron affinity. The third electron, you need the third electron affinity, and so on and so forth. Okay, so if you take an atom like oxygen, it can accept 2 electrons, but in adding the first electron, we will need the first electron affinity. Okay, we need the first electron affinity to get O minus gaseous. Now the first electron affinity for adding electron to oxygen is minus 141 kilojoules per mole. Okay, now notice that we already have O minus in a gaseous state. If we want to go ahead and add another electron, what energy do we need? You are right, you definitely need the second electron affinity, and that is equal to plus 798 kilojoules per mole. Okay, so that is the second electron affinity for oxygen. Now what that means is that in order for us to form an oxide, we take a single oxygen atom and then we want to add 2 electrons to get O2 minus in a gaseous state. We will need to find a total energy of EA1 plus EA2, and that is what? That is minus 141, okay, for the first electron affinity, and then plus 798 for the second electron affinity, and that will give us a total energy of plus 657 kilojoules per mole. So to add 2 electrons to a gaseous oxygen atom, you need 657 kilojoules per mole. Now notice that the second electron affinity is an endothermic process. So second, third, They are always an endothermic process. Take note. All right. So how does all this come together to help us determine the lattice energy? So looking at these three terms that we just talked about, we talk about lattice energy itself, we talk about enthalpy of atomization, and then we talk about electron affinity. So let's take an ionic compound again. Let's take sodium chloride again. So for sodium chloride, to be able to form sodium chloride, we need sodium and we need chlorine. So how is that going to work? Sodium exists as solid metal, okay, but to get it to form an ionic bond, it needs to become a gaseous ion. So the first thing we're going to do is to get it to become gaseous, or is to get it to become atomic, okay. So sodium in a gaseous state as atoms will need a specific amount of energy, and the energy that is required to do that is the enthalpy of atomization, okay. So we are converting sodium to, in a metallic state, to individual sodium atoms, okay. And after we do that, we'll need to get it to become sodium plus. Now for sodium plus, it means that sodium needs to lose one electron. And then in your previous studies, you notice that if we are talking about energy that is required to lose an electron, that we are talking about ionization energy, okay. So in this case, it is the first ionization energy of sodium. So now that we have sodium in its ionic state, what we need next is the chlorine, okay. Now chlorine also exists as gaseous chlorine, Cl2. Now we need to convert it to atom, so we again need what? Enthalpy of atomization, okay. Enthalpy of atomization. So we want a single chlorine atom. Now to balance this, I would like to put half here to balance it. So we'll now have a gaseous chlorine atom, okay. Now we'll go ahead and add one electron to chlorine, and what do we need? We need electron affinity, specifically the first electron affinity, to form a chloride, Cl minus, okay. So now that we have a chloride ion, what that means is that we can go ahead and add sodium plus and then the chloride anion. And this will give us our ionic compound, sodium chloride, okay. Now the energy here is lattice energy. So if we are able to work out the enthalpy of atomization for sodium, we know the ionization energy for sodium, and then we know the value for enthalpy of atomization of chlorine and its electron affinity. We can add all this together, and then we'll be able to determine what the lattice energy is for the formation of an ionic compound of sodium chloride. So this is lattice energy, and watch out for the second tutorial on how to determine the strength of lattice energy of other ionic compounds. Thank you.